Have you ever watched a cake bake in the oven? It's a simple process, yet it holds a world of scientific wonder. It starts as a gooey mixture, a blend of simple ingredients. But with the introduction of heat, something remarkable happens. It transforms into something entirely new, a delicious treat, a testament to the power of chemical change. That's chemistry in action, a real-world example of how substances interact and change. Chemistry is the science of what everything is made of, the very building blocks of our universe. It encompasses everything, starting with the air we breathe, the very essence of life. And it extends far beyond our planet, reaching to the stars in the sky, those distant suns and swirling galaxies. At its heart, it's about tiny building blocks, atoms, the fundamental units of matter. It's about how these atoms fit together to form molecules, how they change and interact, and ultimately, how they create our world, shaping everything we see and touch. Chemistry isn't just bubbling flasks in a lab, a world of complex equations and experiments. It's a dynamic process that's happening everywhere all the time, influencing every aspect of our existence. When leaves turn red in autumn, painting the landscape in vibrant hues, or a match bursts into flame, releasing energy and light, that's chemistry, a fundamental transformation of matter. Even inside your body, in the intricate network of biological processes, chemical reactions digest food, breaking it down into energy, and power your every move, fueling your life. Understanding chemistry helps us understand ourselves, our bodies, and the world around us, providing insights into the very nature of reality. It answers big questions, the fundamental inquiries that have driven human curiosity for centuries. What is the world made of? What are the basic components that make up everything we see and experience? How can we change one substance into another? How can we manipulate matter to create new materials and technologies? For thousands of years, humans have experimented, driven by a desire to understand and control the world around them, sometimes by accident, stumbling upon unexpected discoveries, sometimes on purpose through careful planning and methodical investigation. This journey is filled with fascinating discoveries and breakthroughs, moments of profound insight that have shaped our understanding of the universe. It's a detective story, a quest to uncover the secrets of matter, with clues hidden in rocks, in the geological formations that tell the story of our planet, plants, in the complex chemical processes that sustain life, and even the air, in the invisible gases that surround us. We're all part of this adventure, contributing to the ongoing exploration of the chemical world. So, let's embark on this journey together, venturing into the fascinating realm of chemistry. We'll travel back to the first human discoveries, to the dawn of our understanding of fire and materials, and meet the dreamers who tried to turn lead into gold, the alchemists who laid the foundation for modern chemistry. We'll explore the invisible particles that make up everything, delving into the world of atoms and molecules, and see how they're organized in a beautiful pattern, the periodic table, a testament to the underlying order of the universe. This is the epic story of chemistry, a journey through time and discovery, a tale of curiosity, of the insatiable human desire to understand how things work, imagination and discovery, of the power of human ingenuity to unlock the secrets of the universe. And it's a story still being written today, with new discoveries being made every day, pushing the boundaries of our knowledge. Our story begins long ago in the mists of time with our earliest ancestors. Imagine a world vastly different from our own, a world without the comforts we take for granted, without reliable warmth or the simple pleasure of cooked food. Then came fire, a monumental discovery that irrevocably changed everything for humanity. It was a turning point, a spark that ignited progress. Fire brought light, piercing through the darkness and extending the day. It offered warmth, a refuge from the cold and a source of comfort. Fire also provided protection, warding off predators and creating a sense of security. And crucially, fire unlocked the ability to cook food, making it safer to eat, easier to digest, and undeniably tastier. This marked humanity's first great chemical experiment, changing the very nature of substances through the application of heat, a transformative process. As societies grew and became more complex, so too did their curiosity about the world and the materials around them. People learned to harness the power of fire to make pottery by firing clay, transforming soft, pliable earth into something hard, durable, and waterproof. Then came an even bigger leap, a monumental advancement, the ability to smelt metals from seemingly ordinary rocks. Copper, the first metal to be widely used, then bronze, an alloy stronger than copper, and finally, Iron emerged, the most abundant and strongest of them all. These metals gave rise to stronger and more efficient tools, more formidable weapons, and ultimately, the rise and fall of empires. These transformative discoveries seemed almost magical to those who witnessed them, and those who mastered these skills were often seen as powerful figures holding a special kind of knowledge. The ancient Egyptians, for example, were masters of material science, crafting beautiful glass from the sands of the desert, creating vibrant dyes to adorn their clothing and artwork, and even developing sophisticated techniques to preserve bodies with chemicals, allowing them to seemingly defy death. Their practical knowledge of chemistry was truly remarkable, especially considering it was achieved without the benefit of modern scientific instruments or understanding. This valuable knowledge was carefully passed down through generations, blending practical skill, meticulous observation of the natural world, and deeply held spiritual beliefs about the nature of reality. The very act of transforming dull, lifeless rocks into gleaming, useful metal must have felt like a miraculous feat. For these early pioneers, the boundaries between science and magic were blurred, often indistinguishable. The world was perceived as a place full of wonder and hidden potential, where matter could be manipulated and changed through the application of secret knowledge and arcane techniques. This unique way of thinking, this blend of practicality and mysticism, set the stage perfectly for the next chapter in our story, the fascinating age of alchemy. It was a time of grand dreams, ambitious quests, and the relentless pursuit of hidden knowledge. The groundwork was being laid, brick by painstaking brick, for what would eventually become a new science. And so the adventure continued onward and upward into the unknown. From ancient times, as civilizations rose and fell, humanity has always sought to understand the world around them. A new and mysterious philosophy emerged: alchemy. It was a blend of practical experimentation and esoteric belief. Alchemists were part philosopher, delving into the nature of existence, part mystic, seeking hidden truths through ritual and symbolism, part chemist, meticulously working with substances and reactions, with two legendary goals that captured the imagination of generations. The first was to turn lead into gold, a process known as transmutation, and the second, perhaps even more ambitious, was to find the elixir of life, a potion that promised immortality. They believed purifying metals through intense heat and careful processes could also purify the soul, bringing them closer to enlightenment. And they were convinced that a perfect potion, crafted with precision and infused with mystical energy, could grant immortality, cheating death itself. Their secretive labs, often hidden away in towers or basements, were filled with strange glassware, bubbling concoctions, and coded symbols that guarded their secrets. For centuries, alchemists tirelessly experimented with mercury, a substance they considered vital, sulfur, with its fiery properties, and various acids, each with unique dissolving powers, but despite their dedication and countless attempts, they never quite managed to find gold or achieve eternal life. Yet their relentless pursuit, though ultimately unsuccessful in its primary aims, led to accidental discoveries that would change the course of science. They invented tools and techniques born out of necessity and ingenuity that are still used in laboratories today, like distillation, a process for separating liquids based on their boiling points, and the preparation of strong acids, essential for dissolving and reacting with various materials. Alchemists, through their meticulous experiments, identified new elements and compounds, expanding the known building blocks of the universe, such as antimony, a silvery white metal with unique properties, and phosphorus, a fascinating element that glows in the dark. Hennig Brand, for example, a German alchemist driven by the allure of gold, discovered phosphorus quite by accident while searching for gold in boiled-down urine, a testament to the unpredictable nature of experimentation. Though their dreams of instant wealth and eternal youth were ultimately impossible, their countless experiments, their meticulous observations, and their unwavering curiosity laid the foundation for modern chemistry, the science that unlocks the secrets of matter. Alchemy, in its own way, was a bridge between the world of magic and the emerging world of science, a crucial step in humanity's quest for understanding. Their failures, often spectacular and sometimes dangerous, taught future generations the importance of careful experimentation and objective observation, the cornerstones of the scientific method. The initial quest for gold, driven by greed and ambition, gradually transformed into a quest for knowledge, a deeper understanding of the universe and its hidden laws. And the world, slowly but surely, was becoming ready for a new revolution, a scientific revolution that would forever change our understanding of matter and the cosmos. The age of true science, an age of reason, experimentation, and discovery was about to begin, ushering in a new era for humankind. As alchemy faded, a new way of thinking took hold, the scientific revolution. People wanted proof, not magic, and demanded experiments that could be tested and repeated. Robert Boyle, an Irish scientist, was a key figure in this shift. In The Skeptical Chymist, Boyle argued that science should be based on experiments, not ancient beliefs. He defined an element as a substance that couldn't be broken down further, a revolutionary idea. Scientists began to study gases, discovering that air was a mixture, not a single substance. Joseph Priestley isolated a new gas, oxygen, by heating mercuric oxide. He found that candles burned brighter and animals lived longer in this gas. But the popular phlogiston theory, which claimed burning released a mysterious substance, didn't fit the facts. For example, metals got heavier when burned, not lighter. The stage was set for a major breakthrough. Chemistry was moving from mystical ideas to scientific laws. The search for real explanations was underway. The next great leap would change everything. Chemistry was about to become a true science. Antoine Lavoisier, a brilliant French scientist, solved the mystery of burning. He used precise measurements to show that burning involved combining with a part of air, oxygen, not releasing phlogiston. Lavoisier proved that matter isn't created or destroyed in chemical reactions, it just changes form. He showed water was a compound of hydrogen and oxygen, not an element. His law of conservation of mass became a cornerstone of science. Lavoisier's systematic approach transformed chemistry into a science of measurement. Because of his work, he's known as the father of modern chemistry. Chemistry now had a solid foundation. Lavoisier explained chemical reactions, but what was matter made of? John Dalton, an English schoolteacher, revived the ancient idea of atoms. Dalton proposed that all matter is made of tiny, indivisible atoms, each element with its own kind. Atoms combine in simple whole number ratios to form compounds, explaining why water always has the same proportions of hydrogen and oxygen. Chemical reactions, Dalton said, are just atoms rearranging. His atomic theory gave chemists a new way to understand the world. Though we now know atoms have internal structure, Dalton's ideas were revolutionary. He laid the groundwork for modern chemistry. The secrets of matter were finally within reach. With more elements discovered, scientists needed order. Dmitri Mendeleev, a Russian chemist, found the pattern. He wrote each element's properties on cards and arranged them by atomic weight. Mendeleev noticed that properties repeated in a regular, periodic way. He organized elements into a table, similar ones in columns, creating the periodic table. Mendeleev even left gaps for elements yet to be discovered, predicting their properties. When gallium was found, it matched his predictions perfectly. The periodic table turned chaos into order and revealed the deep structure of matter. It became a fundamental law of nature. Chemists now had a map to guide their discoveries. The periodic table's power was proven. It's still the backbone of chemistry today. Mendeleev's insight changed science forever. The elements were finally in their rightful places. Chemistry's story seemed complete, but the atom held more secrets. Marie Curie, a pioneering scientist, changed our understanding of the atom forever. She studied mysterious rays from uranium, discovering they came from inside the atom itself. Curie called this phenomenon radioactivity. She and her husband Pierre worked tirelessly, isolating two new elements, polonium and radium. Their discoveries proved atoms could break apart, releasing enormous energy. Radioactivity opened the door to nuclear physics and new medical treatments. The atom was no longer indivisible. It was a world of its own. Curie's work revealed the immense power locked inside matter. Her discoveries changed science and medicine. The story of chemistry had entered a new era. The universe was more complex than anyone had imagined, and the quest for knowledge continued. Our journey shows how chemistry grew from fire to a complex science. Chemistry shapes every part of our lives, from soap and clothes to food and medicine. The legacy of early discoveries is all around us, from plastics to power plants. Dalton's atoms and Mendeleev's table are the language of every chemist. Curie's work led to nuclear power and life-saving medical tools. Every new technology builds on the knowledge of the past. Today, chemists tackle big challenges: clean energy, biodegradable plastics, smarter medicines, and nanotechnology. The spark of curiosity that tamed fire still drives us. Chemistry's story is far from over. The future holds new discoveries and solutions. The adventure continues, shaping a better world for everyone.